Welcome to Cybersecurity from Scratch, Technical Foundations, Episode 10.1, Hashcat Tutorial. In today's episode, we're first going to talk about what Hashcat is and what it's used for, and from there we're going to go into some basic use cases. Spoiler alert, it is designed for cracking passwords, and we're going to open with a basic password cracking use case. Next, we're going to talk about a little more complicated example where a rules engine is used to crack passwords. We're going to go into the Hail Mary scenario where we're going for a brute force attack with it. And then finally, we're going to talk about some advanced configurations. The creators of Hashcat market it as a, quote, advanced password recovery tool to emphasize the blue team objective of simply recovering passwords that you own but have somehow forgotten it or lost access to. However, for pen testers and red teams, it's an invaluable tool for cracking other people's passwords. It's a more powerful version of John the Ripper, but it's a little bit less intuitive, so we'll talk a little bit about its configurations. A basic word list crack for Hashcat looks a whole lot like John the Ripper. You have a hash file that you're trying to crack, and you give it a word list. The different thing here is that you're also passing in this -m flag, which gives the index of the type of hash you're trying to crack. It's not the most intuitive thing in the world. You actually have to consult a lookup table to figure out what sort of hash you're passing into the function. In this case, -m13100 corresponds to Kerberos 5, and so Hashcat knows what the hash is and will go for it. It's kind of nice that John the Ripper will identify it for you. However, Hashcat, by forcing you to identify explicitly what your hash is, it removes any ambiguity in the equation for figuring out what the type of hash is. I've included a link here for where this lookup table is, and I'll put it in the show description as well. Remember that RockU is the gold standard for if you're running a Capture the Flag challenge, and that's usually why we use that for examples. Now let's try running Hashcat. We can get status updates as it goes, and we can see that it's chewing through the RockU word list very quickly. Victory. We got our password. Now, in the real world, it's usually not quite so easy. People aren't usually using passwords right off of the sheets. And so in a real engagement, a lot of times what an attacker is attempting to do is identify a pattern that someone might be using for their password, and then will be using permutations off of that root to try to figure out what the password is. And so Hashcat can be used to facilitate this. This is why the scheme of doing, new $ password, hash sign, and then some incrementing number is a terrible idea, because you can really easily get around this with one of these rules engines. And so the syntax for doing this is you give the hash like normal, and you give a base passwords file like normal, but then you also use a -r flag to specify a rule. I'm going to include a link into a GitHub page for a rule that I particularly like using on CTF challenges, and which very effectively gets around a lot of these basic permutations. So let's see this in action. We're reasonably certain that our password is going to be some permutation off of these bases right here. Please subscribe and you've got mail. But we want to pass it through our rules engine. So what we're going to do is fire up Hashcat. And this is going to take quite some time. So we have 2 base passwords, 1 hash that we're testing. And we can see that it's moving at a relative snail's pace. But we can see what's happening is that the engine is doing permutations off of that root password. So we're going to take a little break, and we're going to come back in however long it takes to crack this. And 20 minutes later, we're done. We can see the output looks pretty much like the other example where we have the hash up front and then the password right here. Oftentimes there is no root password or something that an attacker might know, and therefore what they're going to try to do is a brute force attack. Hashcat will allow for brute forcing, but it's a little more clever than just a strict brute forcing of all possible characters. The creators know that oftentimes people follow specific patterns where they'll have letters followed by a special character followed by numbers or something like that. And so what you can do is, in doing the brute force attack, set up a specific masking so that only particular characters will be tested at particular sequences within the password, and this can shave years off of the password crack time. Like a true brute force password would oftentimes take years, but with a great limiting of that password set, it can be done in much, much less time. I'm not going to give a demo and get too deep into this because the use is a little more limited in penetration tests and CTF challenges, but if you're interested, I've included a link to the description for this. To further maximize its potency, Hashcat allows video cards to be used for cracking passwords. Since video cards have many tiny processors which are good at small, discrete mathematical operations, they're perfect for computing hashes, which is why people use them for mining cryptocurrencies. But the technique also works equally well here for password cracking. To enable a GPU to be used as well as a CPU, OpenCL has to be installed for the particular card and the particular system configuration that you're using. And this is of course going to vary depending on the type of system and the type of video card you have. To verify that the Hashcat can actually identify the tool that you're trying to use, you can run hashcat-I, uppercase I, and this will identify all the different devices that are able to be used. And then when Hashcat is run, you can use the -D flag and then specify a comma-separated list of which devices. So your CPU will be one, your GPU will be another. If you have multiple GPUs, that'll be lined up. And so professionals will often use custom boxes that have multiple GPUs to sort of farm out these cracking tasks across multiple GPUs. And in this way, even brute forcing attacks can be made viable.